Third grade unit 6 is about properties of operation. We actually start by going back to area and composite area and talking about rectilinear figures. Students have to split it, find new side lengths based on what they're seeing here, and then they can multiply areas and put them together like this. And they talk about how a shape like this shape that looks like this has an equation that can't really be simplified. Like all I can do here is do the multiplication and put it together. We could take a shape like this and we could rewrite this as a different multiplication equation because we could think of it as one big rectangle. Putting those together, we could think of it as this. And I've already mentioned this shows the distributive property, but it doesn't just show the distributive property because we notice something about the numbers we've been given. It shows something about the distributive property because of the picture we can draw that it represents. This picture makes a rectangle and this picture doesn't. And that's really, really cool and launches us into thinking about other properties. Here I can think of this as the height, 5, getting multiplied times this base, 4 times 10. And so I can think of it as 5 times 40. There's the base getting multiplied by the height. Or I could think of it as this being the base, right? And doing 5 times 4 is the base. And now this is the height. So as long as we're multiplying 3 numbers, 5 times 4 times 10, we can twist the shape and turn it around, and it doesn't really matter the order in which we multiply these numbers. What's cool here is that this one helps us do numbers like that now, because we can really think of them as 5 times 4, and then think about what multiplying by 10 means. And then finally, we take that one step further by looking for those properties and then moving on to looking for patterns in the addition table and in the multiplication table. For example, in the addition table, I can see here that 6 plus 2 is the same as 2 plus 6, right? And I see that pattern going through the entire table, 7 plus 3 and 3 plus 7. That's why the table has this nice diagonal, right? I can see the 0 property depending on if there's a 0 column. I can also see other patterns, and this launches us into noticing, for example, that when I add 2 to another even number, 2 plus 2, 2 plus 4, 2 plus 6, 2 plus 8, that my answers are always even, and talking about why that is. So that's one more thing that is explored. Except for multiplying by